Okay, continuing with Module 9, we're going to talk about conditions for parallelograms today, which is going to seem very similar to the properties of parallelograms. But we're going to go ahead and label 76 and 77 conditions for parallelograms. So go ahead and turn to those pages, 76 and 77. I'm going to get something underneath this page so I can write on it. So 76, 9.2 conditions for parallelograms. All we're talking about this week is parallelograms. Technically, all next week too, but you know. So there is a difference between properties of parallelograms and conditions. It's almost like converses and a theorem. Conditions are going to kind of be the opposite. So in 9.1, when we have properties, we said, hey, here's a parallelogram. Here's what you know is true since you know it's a parallelogram. Well, the conditions today is going to be the opposite. It's going to say, hey, we have these certain properties or conditions that are true. Can you say if it's a parallelogram or not? So we're actually going to be proving that something's a parallelogram now with the properties we talked about yesterday. So kind of going in the opposite direction there. So we're going to write something down. This you have seen, but there are a number of ways to prove that a quadrilateral is a parallelogram. So we're going to go in the opposite direction. We're not going to be given it's a parallelogram. We're going to be given conditions to determine if it is a parallelogram. However, the three things still remain the same. I still color coordinate them like I did yesterday or 2 days ago. My screen froze, so you can't see what I wrote, so let me fix that real quick. Clear this where it wrote on it. There you go. Pause it if you need to, because I'm just going to move on, but I know you can pause it to write down the sentence there. So each of these is technically a theorem. So if the opposite sides are congruent, then it is a parallelogram. And I'm not going to write then it is a parallelogram over and over again. We're going to write it once at the end. If the opposite angles are congruent, then it is a, sorry, the bell rang. Then it is a parallelogram, and it will ring again in 1 minute. Or if the diagonals are congruent, not congruent, bisect each other. Then it is a parallelogram. Now, something you should know, only one of the three has to be true. However, it could actually be a mixture. You might have one set of opposite sides congruent given to you, and you might have one set of opposite angles congruent to you, but you can still say it's a parallelogram. Okay, so you might have one opposite side, one opposite angle. Normally, you're going to have both opposite sides, both opposite angles to use these conditions. However, it is okay to have one of each. So the then part of that is then the quadrilateral must be a parallelogram. So these are all the conditions, the theorems that go with those conditions. I told you I always have to really double check and make sure I didn't spell parallelogram wrong. You would think after writing it for that many years I would remember, but I don't. Okay, we're going to do some proofs mostly today then. So you need to tear out page 4, I'm just going to go ahead and tell you all of them, 433, 435, 438. Go ahead and tear all those out, and we'll get started. We won't glue them all in at the same time, but we'll go ahead and get started on them. Okay, 433. You need from the box theorem all the way to the end of the page with that proof there, because that's the proof we're going to do. And we're going to prove 2 of these. I think you proved the other one in homework. Okay, so glue this in. This is from 433. Will just fit from here all the way down to the proof. Just fit on 76. Okay, so here's what we are proving. If both pairs of opposite sides of a quadrilateral are congruent, this red one up here, then the quadrilateral is a parallelogram. So we obviously can't use this. That is what we are proving. Okay, so it says, complete the proof. Given that AB is congruent to CD and AD is congruent to CB. So we're saying, given that the opposite sides are congruent, we're supposed to prove this is a parallelogram. Okay, and in order to do this, we are probably going to prove that the triangles are congruent and then use one of these others. We're either going to use opposite angles or that the diagonals bisect each other. And opposite angles will actually be the easier one to use because I don't have to worry about the bisecting thing. I'd have to prove 2 sets of triangles are congruent. All right, so it says first A, draw diagonal DB. And it says, why is that helpful? We need a pair of triangles to prove this. You almost always need triangles. Okay, so now let's focus. Draw DB, we did that because through any 2 points there's exactly one line. Now DB is congruent to DB. Why? Reflexive property. You should know that one in your sleep. Okay, next. AD is congruent to CD. Sorry, AB, I can't read. It's congruent to CD. And AD is congruent to CB. That's given. Notice they didn't put the givens first. That's okay. It doesn't hurt. You know, if you didn't need to use the givens before, it doesn't matter. All right, next it goes ahead and says, hey, ABD is congruent to CBD. Well, that's because we have side, side, side. Okay, next, ABD is congruent to CDB, and ADB is congruent to CBD. Well, that is because they are corresponding parts, congruent triangles or figures. Okay, here's what it's doing. Once we've proved we have 2 congruent triangles, they are trying to show you, this is back in 4.1, 4.2, no, 4.3 is where it is, way back in your notebook. When we proved that lines are parallel, we could use corresponding angles or alternate interior angles. If we have that those are congruent, then, and that was the converse of those, if we know that those angles are congruent, that means that the opposite sides are parallel. So that's actually what we're going to use here. So since these angles are congruent, they are alternate interior angles. Well, since we have alternate interior angles congruent, we have 2 sides parallel. So that is because of the converse of the alternate interior angles theorem. That is back on in 4.3. It's been a while. Well, since the opposite sides are parallel, it is a parallelogram by the definition of a parallelogram. So, if you are given opposite sides congruent in a quadrilateral, it is a parallelogram. There's the proof that goes with that to tell you that that's true. Okay. All right, next, from 435, you're going to cut out from the theorem all the way down to the end of the page there. We're going to prove the diagonals one. We're just not going to prove the angles one. If you do, I think you do it in homework. This will be all you need from 435, and we're going to glue this, oops, my straight edge left, on 77. So glue from the theorem all the way down to the box, 77. Okay, so now if we have diagonals that bisect each other, then we are going to show that the quadrilateral is a parallelogram. All right, and so we actually are going to end up using one of the 3 conditions this time. All right, so let's go ahead and start. It says, given that these AE and CE are congruent to, AE is congruent to CE and DE is congruent to BE, that's given to us. That's the idea that the diagonals are bisecting. Okay. We also then know that AEB is congruent to CED, and AED is congruent to CEB, and that is because they are vertical angles. That's the vertical angles theorem. Okay, and then we need to think about what we're actually trying to do here. Here's what we're trying to do. We're trying to show this is a parallelogram. To show this is a parallelogram, if I show that all 4, so this triangle, as well as this triangle and this triangle, are congruent to each other, then I'm going to be able to say the opposite sides are congruent. And if the opposite sides are congruent, as I've just proved, then I know this is a parallelogram. Okay, so that's what we're doing. We have enough information to say that these opposite triangles are both congruent, and we are going to say that both of them are congruent. Okay, so AEB, we'll start with this one, is congruent to CED, and AED is congruent to CEB because we have side angle side. Okay, that then gives us that the opposite sides, AB and CD, are congruent, as well as AD and CB. And that is because they are corresponding parts of congruent triangles or figures. If you put F instead of T, that's fine. Right? Then, since I have opposite sides of the quadrilateral congruent, I know that it is a parallelogram. That is a condition or property of parallelogram. It is not the definition, because that's only if you're saying something is parallel. Okay? All right. Last, we're going to do some algebraic kind of examples. So 438, you're cutting out 6 and 7. And we're going to glue 6 and 7 right underneath this proof because we're going to need as much room as possible. Y'all ever feel like these notes are like a ransom note or something? Because sometimes I do. All right, so 6 and 7. It says, show that each quadrilateral is a parallelogram for the given values of the variables. So let's look at number 6 and see what we've got. Number 6 We have opposite sides, QP and RS. We'll have to see if those are really congruent if A is 2.4. But then I got a problem. So like I don't have both opposite sides, but as long as I have one set of opposite sides and one set of opposite angles, I'm good. I don't have opposite angles. Here's what I've got. I've got something called consecutive angles. Q and R are consecutive angles. Okay? Consecutive angles means they happen one right after the other. So Q and P are also consecutive angles. R and S are consecutive angles. S and P are consecutive angles. In a parallelogram, since the opposite angles are congruent, consecutive angles are supplementary. Okay? So, if the opposite sides are congruent, one set, and the consecutive angles are supplementary, then I will be able to say that this quadrilateral is in fact a parallelogram. So let's start with the consecutive angles. So 10, and instead of B, I'm going to put 9, minus 16, supplementary, remember, adds to 180, plus 9 times 9 plus 25 should be equal, we don't know, to 180. We're going to see if it is. If it is, then that'll be half of the, we got to show that this is a parallelogram. Remember, it's either both opposite sides, both opposite angles, or a mixture of one opposite side, one opposite angle, or a consecutive angle supplementary. So let's see, we've got 90 minus 16 plus 81 plus 25. Does that equal 180? 90 minus 16 is 74. 74 plus 81. 75. 155. 155 plus 25 is 180. So, angle Q and angle R are supplementary. So we got that part. That helps. Now let's talk about the opposite sides. So they should be equal. So 7A, but instead of A, I'm going to put 2.4. That looks awful. 2.4 should be equal to 2 times 2.4 plus 12. I'm really not feeling doing that in my head. So 7 times 2.4 is 16.8. We don't know if they are. And 2 times 2.4 plus 12 is 16.8. So QP is in fact congruent to SR. So I know that I have one set of consecutive angles supplementary, one set of opposite sides congruent. So therefore, by the way, a nice cool mathematical thing that you probably don't know at this point, 3 dots in a triangle actually means therefore in math. Therefore, QRSP is a parallelogram. Okay, pause the video, try number 7 where you have diagonals. All right, number 7, diagonals. Since the theorem says if the diagonals bisect each other, we have a parallelogram, we have to determine whether they actually bisect each other. And for them to bisect each other, Jn must be equal to Ln. So we're going to start there. So what needs to happen is 2x, but instead of x, I'm going to put 6, plus 2 needs to be equal, we don't know, to Ln, which is 4 times 6 minus 10. Okay, and that's 12 plus 2. 24 minus 10. and that is 14 equals 14. So we're good. So Jn is congruent to Ln. That helps us. That's one of the pieces. Okay, next. Mn should be congruent to Kn, and we're going to use 3.5 for y. So 6 times 3.5 plus 1 should be equal, we don't know, to 8 times 3.5 minus 6. And again, I don't really feel like doing the decimals in my head. 6 times 3.5 is 21, plus 1 is 22. Let's see if it really is equal. 8 times 3.5 is 28, minus 6 is 22. So that works. So Mn is congruent to Kn. Since both diagonals are congruent because they have been bisected, we know, so therefore, JKLM is a parallelogram. Okay, so today you're doing more proof. Hey, here's these properties or conditions. Show me it's a parallelogram. Where yesterday or 2 days ago, whenever it was, hey, here's these properties. Hey, here's this parallelogram, and you know these things are true. So kind of the opposite. So go ahead and get started on your work, and I'll see you on the next video.